All right. Good evening. Good evening, online students.
Good
Good
evening.
evening, ma'am.
Evening,
ma'am.
Yeah, good evening. I've shared my screen. You can see multiple choice questions, 1 to 5.
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. Answer the first one.
Ma'am,
You don't
rational
have to,
number.
yeah, you don't have to write anything as of now. I'll give you instructions. For now, you don't have to write.
Rational
For now, you don't
numbers.
have to. Yeah, for now, you don't have to write anything. Yeah. The first one, a number which can be expressed as P by Q, where P and Q are integers and Q not equal to 0 is a rational number.
Rational number.
Very good.
Rational number.
Yeah. Next one. Which of the following is not true?
Ma'am, A, ma'am.
Okay.
Ma'am, D. I think so. It's D.
I think it's D, ma'am.
Ma'am, I
D.
mean to. Yes,
Okay.
ma'am. D.
Okay. So rational numbers are closed under addition, which means rational number plus rational number is equal to rational number. Rational number plus rational number is equal to rational number. True. Rational numbers are closed under subtraction, which means rational number minus rational number is equal to rational number. Yes, true. When you subtract two rational numbers, the result or the difference will be a rational number. The third one, rational numbers are closed under multiplication, which means rational number into rational number is equal to rational number. True. Rational numbers are closed under division. This is not true because we have one exception. Yeah, it's not always true because we have only one exception there. Because when the denominator is 0, that is the second rational number is 0. Rational number divided by 0 is not a rational number. Rational number divided by 0 is not a rational number. Rational numbers are closed under division. Are closed under division is the statement.
I'm not
But
defined.
yeah, this one is not true. A rational number divided by 0, which is a rational number,
Yes, ma'am.
is not a rational number. So this is false. It says rational numbers are closed under division. No, rational numbers are not closed under division because when the second rational number, that is when the when the denominator is 0 or the second
rational number is 0.
yeah, then division by 0 is not defined. So this is not true. So the correct option is option D. Option D is the correct option. Zero is, yeah, go through the options and tell me the correct option.
Ma'am, identity for addition of rational numbers.
Ma'am, A,
A.
ma'am.
A.
A.
A, ma'am.
A, ma'am.
Zero is the identity. Identity children, not identify. The first, it's not identify, it's identity. Typing mistake. Okay. Option A, the identity for addition of rational numbers, the identity for subtraction of rational numbers, for multiplication of rational numbers, for division of rational numbers. Is identity for addition of rational numbers. Because identity means you get the same answer or identical answer to a rational number. When you add 0, you get the same rational number as the result. Rational number plus 0 is equal to rational number. You get the same rational number as a result. Identical answer, same answer. So identity, identical identity. So 0 is the identity for addition of rational numbers. Is the correct option. Next one. 1 is the
Ma'am, multiplication, ma'am.
Identity of rational numbers.
correct, because
Option
rational number into 1 is equal to rational number. Rational number into 1 is equal to rational number. When a rational number is multiplied by 1, the product is the rational number itself. You get the same answer, identical answer, same answer. So 1 is the multiplicative identity of rational numbers. Last one.
Ma'am, A, ma'am.
Identity for addition of rational numbers.
A, ma'am.
Yeah, because rational number x plus 0 is the same as 0 plus rational number x is equal to x. That is x plus 0 is x. 0 plus x is also x. Same answer, identical answer. So additive identity or identity for addition of rational numbers. Identity, this is the identity for addition of rational numbers. The first one. Yeah. I'll tell you what you've tried. Yeah. Fill in the blanks.
Ma'am, is it 45 by 63?
With numerator 45.
45 by 63. Yes, ma'am, I got the
45 and 63.
63, ma'am.
Because you multiply it by 9, ma'am.
Correct. 45 by 63. Correct. Next one.
Thirty-five by 45.
Correct.
Can we simplify it?
You'll get back 7 by 9.
Yeah.
So you should not simplify because the denominator should be 45. So if you simplify, then the denominator will change. No, it will not be 45.
Yes, ma'am.
Yeah.
Ma'am,
Between
next one,
the number
40.
Yeah, Dhanvin?
Ma'am, next one, 35 by 40 is the answer.
Okay, between the numbers 15 by 20 and 35 by 40, the greater number is
35 by 40.
okay. So you can just bring this to compare the two numbers. You'll have to bring them to the same denominator. So just multiply this by 2. So what is this equal to? 30 by 40. 30 by 40 and 35 by 40. So now the denominators are the same. So compare the numerators. 35 is greater. So 35 by 40 is greater. Bring the two numbers to the same denominator. You can bring them to the LCM or any same denominator. LCM is the smallest denominator, smallest common denominator. The LCM of 20 and 40 is 40. The LCM of 20 and 40 is 40. So you bring 20 to 40 into 2 into 2. So it's 30 by 40. Now compare 30 by 40 and 35 by 40. Greater the numerator, greater the fraction. Yeah, next one. No, again, there's a printing mistake. Sorry. For rational numbers A by B, C by D, E by F, meaning typing error. Okay, we have A by B. This is A by B, children.
Ma'am, associative, it's, I think
Ma'am,
so it's
yes.
associative
Ma'am,
property.
distributive property.
Distributive
yeah.
property.
A
Distributive
into
property.
B plus C is equal to AB plus AC.
Correct. But
A by B.
A by
into C.
B, yeah, into C by D. You're right. You're right. A
Maybe
by
A by
B,
B into E by F.
A by B
Into E by F.
into E by F. Correct. Correct. A by B into C by D plus, because there's a plus sign here, plus A by B into
E by
A by
F.
B into E by F. Correct.
Ma'am, minus 5 by
Ma'am,
7.
minus 5 by 7 is less than minus 3.
Yes, ma'am.
Think.
Ma'am, it will be. Ma'am, no, ma'am, it is greater, ma'am, because it is negative. Minus 21 is less than minus 5.
Ma'am, I
So,
can't understand.
yeah. I'll explain.
Ma'am, got it.
Correct. So consider the number line. We have 0 here, -1, -2, -3. This is -3. And what is minus 5 by 7? It's less than -1. Meaning less than, it will be here. Minus 5 by 7. It will be before -1, right?
Yes,
Okay,
ma'am.
because, yeah. Okay, what's the value of 5 by 7? 5 by 7 is a proper fraction. No, its value is less than 1. Forget the minus sign. 5 by 7 is a proper fraction. Its value is less than 1. So minus 5 by 7. What is minus 7 by 7, children? That is, what is this minus 1? This is minus 7 by 7. Minus 1 is minus 7 by 7. So minus 5 by 7 is here. Minus 6 by 7, minus 7 by 7. This is minus 5 by 7.
Yes, ma'am.
So on the number line, as you move towards the left, the numbers keep decreasing in value. As you move towards the right, as you keep moving towards the right, the numbers increase in value. As you move like this, when you move like this, it increases, decreases. So here is minus 5 by 7, here is minus 3. So as you move like this, the value decreases. So minus 5 by 7 is greater than minus 3. Very. Yeah, you can find the LCM, you can bring them to the same denominator. Correct, yes. Got it?
Yes, ma'am.
Minus 5 by 7 is greater than minus 3 because you can see minus 5 by 7 will be here on the number line. This is minus 3. As you, walk towards the left, as you walk like this, as you go like this on the number line, the value will keep decreasing. So that means minus 3 is smaller than minus 5 by 7, which means minus 5 by 7 is greater than minus 3. Yeah. Minus 3 by 4 is smaller than minus 2. Minus 3 by 4. It'll be, this is minus 1, which is minus 4 by 4. So this is minus 3 by 4. Correct? Minus 1 is minus 4 by 4. So where will you mark minus 3 by 4? See, this is 0 by 4. This is minus 1 by 4. 1. This is 0 by 4, which is 0. This is minus 1 by 4. This is minus 2 by 4. This is minus 3 by 4. This is minus 4 by 4, which is minus 1. Okay, and then minus 5 by 4, minus 6 by 4, minus 7 by 4, minus 8 by 4. This is minus 2, correct. This is minus 2. And we know as we move towards the left, the value keeps decreasing. So minus 2 is less than minus 3 by 4. That means minus 3 by 4 is greater than minus 2, correct? It's just the opposite thing. It's just the opposite. In the case of a positive number, what will you say? Compare this one. Compare this. 3 by 4 is smaller than minus 2. Sorry, 3, just take it as a positive. 3 by 4 plus 3 by 4 is smaller than plus 2. True or false? True. Then it's the opposite answer. Minus 3 by 4 is smaller than minus 2 is false. When you compare one negative and one positive number, when you compare one negative and one positive number, obviously the positive number is greater. When you compare a positive value and a negative value, obviously the positive value is greater or the negative value is smaller. When you compare two positive numbers, you know which will be greater. When you compare two positive numbers, you know which will be greater. When you compare two negative numbers, it's the opposite answer. The number which looks big is the smaller number. So when you compare, like minus 3 by 4 and minus 2, 2 is actually, when you compare just 3 by 4 and 2, 2 is big. But when both are negative, 2 is minus 2 is small.
Mom, I have a doubt, Mom.
Yeah?
Mom, in the last fifth question, Mom, the question was minus 5 is great answer is greater than minus 3. How, Mom? But in this question, we are saying that it's smaller than minus 2, right?
Oh, okay. Now tell me, is this true? 5 by 7 is less than 3. Is this true?
Mom,
5 by
false.
7.
False.
No, 5 by 7 is less than 3, no? Because 5 by 7 is a proper fraction. Its value is less than 1.
Okay.
Okay, fine. See, 5 by 7. What is 3? 21 by 7, right?
Yes, Mom.
What is 3? 21 by 7, correct?
Yes, Mom.
Now the denominators are the same. Compare the numerators. 5 is less than 21. True or false?
True, Mom.
5 is less than 20. This is true, right? So this one is true. Five by 7 is less than 3 is true because 3 is nothing but 21 by 7. Now the denominators are the same. So compare the numerators.
Okay, Mom.
5 is less than 21. True. 5 is less than 21. True. Now when you take the negative of these numbers, minus 5 by 7 and minus 3, You should take the opposite sign. Minus 5 by 7 will be greater than minus 3.
Now I understand, ma'am.
Okay. So similarly here, when you compare their negatives, that is 3 by 4 and 2. What is 2? It's 8 by 4. 2 is nothing but 8 by 4. Now compare 3 by 4 and 8 by 4. 3 by 4 is less than 8 by 4 because the denominators are the same. So compare the numerators. 8. 3 is less than 8. True. This is true. That means this is true. I'm talking about this question. 3 by 4 and 2. 3 by 4 and 2. 2 is nothing but 8 by 4. Now, here the denominators are the same, 4, 4. So compare their numerators. 3 is less than 8. Yeah, 3 is less than 8. True. That means 3 by 4 is less than 2 is true. But when both the numbers are negative, minus 3 by 4 and minus 2, the inequality will be reversed. Minus 3 by 4 is greater than minus 2.
Okay, ma'am. Now I understand, ma'am.
All right. So now the statement, the correct statement is minus 3 by 4 is greater than minus 2. But it's given smaller, so it's false. The statement is false. So minus 3 by 4 will be greater than minus 8 by 4. Minus 3 by 4 is greater than minus 2. But it's given smaller, so this is false. 0 is a rational number. 0 is a rational number.
Yes, ma'am, because it can be expressed in the P by Q form.
Ma'am, yes, ma'am.
Okay.
It's a
0 by
rational number, ma'am.
Correct. Every fraction is a rational number.
Yes, ma'am.
Every
Because
fraction
it
is a
is
rational.
expressed in the P by Q form.
Correct. Every integer is a rational number.
False.
Who said false? Now take the integer minus 7. Minus 7 can be written as minus 7 by 1. Integer by integer. Rational number. If the number does not have a denominator, the default denominator is 1. If you think the number does not have a denominator, so it is not a rational number because it does not have a denominator. So it's not a rational number. Every number, if there is no denominator, the number has a denominator 1. Now supposing the number 10. Yeah, 10 does not have a denominator, but the default denominator is 1. So integer by integer, rational number. So every integer is a rational number because every number can be written. Every number, whether it is a whole number, a natural number, or an integer, it can be written in the P by Q form. If there is no denominator, you can take the denominator as 1. So every integer is a rational number is true. If you consider the integer 3, 3 is 3 by 1. Integer by integer, P by Q form, rational number. Yeah. If x and y are two rational numbers such that x is greater than y, if x and y are two rational numbers such that x is bigger, x is more than y, the value of x is more than the value of y, then x minus y is always a positive rational number. Yeah, bigger number minus smaller number. No, I have not given any answer. I'm asked big number minus small number is positive always. Is the question.
It's true. It's true. True, ma'am.
No, the rule, see, big number minus small number will always be positive. That's what the statement is conveying. Is it true or false?
Excuse me, ma'am.
Yeah.
Ma'am, I couldn't understand the fifth question. Can you repeat it again for me?
Fifth one, huh?
Yeah, yes, ma'am.
No, the statement is there. You read the statement. We haven't discussed the answer yet. You have to tell me.
Oh, sorry, ma'am. I thought you discussed the answer. Okay.
Please read the fifth statement. I'm just trying to tell you. The statement says two rational numbers, x is greater than y. Then when you subtract x minus y, when you find the value of x minus y, the answer will be positive. Is what the statement is telling you. Is that true or false? Yes. True or false, children?
True.
True. The difference when you subtract, when you write, when you
Ma'am,
answer
larger number minus smaller number is always positive.
positive, yeah. A greater number minus a smaller number is always positive. If you write the bigger number first, you have two numbers. You write the bigger one first, and then you write the smaller number. So this difference will always be positive. It will always be positive. It won't be negative. X and Y are two numbers. This is big. This is small. When you find big number minus small number, the answer will be positive. Answer, we don't know what it can be because we don't know the numbers. It will be a positive answer. It won't be negative. Negative will be when you subtract, when you do small minus big, like 10 minus 20, it's minus 10. It's negative. When you perform small minus big, 10, 20, 10 is smaller than 20. So when you do small 10 minus big 20, 10 minus 20 is minus 10. Then you get a negative answer. Sorry. So is the last statement true? Akshita?
Ma'am?
Last one is true. Do you understand that?
Ma'am, but I'm having a doubt, ma'am. But how, ma'am, if the x is like in negative form, how it can always be like positive, ma'am? How it can always be a positive rational number, ma'am?
If it's negative, you're saying, is it?
Yes, ma'am. What if x is a negative rational number? It can't always be a positive rational number, right?
Okay, we'll check that with an example. See.
Ma'am,
We'll
like
check
minus 25 minus 5, ma'am.
Yeah, we'll do that. We'll do 1 minute. I'm coming to that. Okay, so we'll consider both the numbers negative. Okay, so we'll take x as a bigger value, say like minus 5, and y cannot be minus 4 because minus 4 is bigger than minus 5. So see on the number line, select, you tell me minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. So if you take minus 5, if x is minus 5, this is big. So if you want to select a smaller number, you should select from here, not from here, not from here. So select one smaller number from here, say minus 8. Now we'll find x minus y. What is x? Minus 5. Minus, what is y? Minus 8. This is x. This is x minus 5. This is x minus 5. And this is y minus 8. X minus y. See, x I have written here in the bracket minus 5. Y I have written here in the bracket minus 8. And this is the minus sign. This minus. This is x, this is y, this is the minus sign. Now it will be minus 5, minus into minus plus 8. And minus 5 plus 8 is plus 3. It's positive. Correct.
Mom, now I understand, Mom.
Very good. Okay.
Mom, can you show the previous slide, Mom, so I could take the screenshot of that some answer, Mom?
Yeah.
Done, Mom.
Yeah. So the assertion statement we have, natural numbers are closed under multiplication. Natural numbers are closed under multiplication. That is, when you multiply two natural numbers, the answer is also a natural number. When you multiply two natural numbers, what are natural numbers? All counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. When you take any two natural numbers and multiply them, the answer is also a natural number. Okay? By which letter are natural numbers represented or denoted? N. So the assertion statement says natural number into natural number is always a natural number. True. When you multiply two natural numbers, the answer will be a natural number. The reason statement says a rational number is a number that is in the form of P by Q, where P and Q are integers and Q is not equal to 0. Now, natural numbers are closed under multiplication. Is it correct? Yes, because natural number into natural number is a natural number always. So this is true. That's what we mean by the closure property. How do you check the closure property? So for this statement, natural numbers are closed under multiplication, meaning natural number into natural number. The answer is a natural number. When we multiply two natural numbers, the product is also a natural number. True. So the assertion statement is true. And the reason statement is a rational number is a number of the form P by Q, where P and Q are integers and Q not equal to 0. Yeah, correct. Q is not equal to 0. True. Yeah. So see the options we have. Both assertion and reason are true. Yeah, actually they are true. And R is the correct explanation of A. No, both the both the assertion and reason statements, they're talking about two different facts. Both are facts, but they're two different facts. Sorry? Correct. So that both assertion statement and reason statement, both are true, but the reason is not talking about the assertion. So the reason is not the correct explanation of A. The second one says both A and R are true, but R is not the correct explanation of A. Correct. This is correct. Now, this one is not applicable because here they're saying R is false. No, so this will not come. Here they say A is false. So this also is not applicable. Because for us, both the statements are true. So we have to select one of these two options. For us, this is true. This is also true. So we have to select either this or this because in only these two options, we have both A and R are true. So we have to select this or this. And this is wrong because the reason is not the correct explanation of A. They are talking about two different things. So this is the correct option. B is the correct option. Yeah, read the second one. Rational numbers are commutative for division.
Ma'am,
Rational
no.
numbers are
Ma'am, no, ma'am.
rational numbers are commutative for division. Commutative meaning A divided by B, like 10 divided by 5 is the same as 5 divided by 10.
Ma'am, no.
No, 10 divided by 5 is 2.
No, ma'am.
5 divided by 10 is 1 by 2. No, rational numbers are commutative for division. No, commutative means A divided by B is the same as B divided by A. No, 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 false. The reason statement is rational numbers are commutative under addition and multiplication. Yes, yes, they are. A plus B is equal to B plus A. A into B is equal to B into A. So this is false and this is true. So A is false, R is true. This is the correct option. No, that will, no, you will have only standard these four options. Because only when both are true, you will get that, the rest of the, otherwise you will not get it.
Ma'am, should we write all these before the next class?
No, no, no,
Okay.
you don't have to. Yeah. Name the property. under multiplication used in each of the following.
Mom, first one is closure property, mom.
Correct. The first one is closure property.
Ma'am, next one is commutative property.
Commutative property,
Commutative
ma'am.
property.
So one
Ma'am,
second.
next one is
Commutative
associative
property.
property.
So this will not be interesting because all of you are shouting out answers for different questions. We are still in the first one. I haven't taken you to the second one at all. Okay, we are still with the first one. And Akshita said closure property. I want you to complete it. Closure property, complete it. You need to use certain other terms.
The multiplication of two rational numbers is always a rational number.
Correct.
Mom,
Rational numbers are always closed under multiplication. Or as Anirudh said, what did you say, Anirudh? The product
of two rational numbers is a rational number.
Correct. The product of two rational numbers is always a rational number. The product. So name the property under multiplication used in each of the following. So the first one is the closure property of addition. Sorry, the closure property of multiplication of rational numbers. Rational numbers are closed under multiplication. This one is closure property. Disable your mic, Akshita. Closure property of
Closure property of rational numbers.
yeah. Next one.
Ma'am, commutative
property of multiplication, mom.
rational numbers.
Commutative property
Of rational numbers.
Of multiplication of rational numbers.
Correct. Of multiplication.
Of rational numbers.
Third one.
Associative property.
Property of
Property
rational
of
number.
multiplication of rational numbers, mom.
Correct. Associative property.
Of multiplication of rational numbers.
Correct. Very good. Yeah. Yeah, now start working. Now open your tuition classwork notebook. Take down this question and answer this. What we've discussed so far, you don't have to write in your notebook, children. If you want to write, you can leave some pages. You just count. Yeah, you can do that. I've shared all the images on WhatsApp. If you want to leave some space, you can leave some space and finish it later. Now take down this question, answer this. minus
25 by 24.
minus 25 by 24. Okay. What must be subtracted to minus 7 by 8 to get 7 by 12?
Ma'am, I got 7 by 24.
Okay, so let the number be x. What must be subtracted to minus 7 by 8? So how do you to get 7 by 12? So what's the equation?
7 by minus 7.
What must be subtracted 2 minus 7 by 8 to get 7 by 12? Have you all got this equation?
Yes, ma'am.
So when you transpose, what do you get? Minus x is equal to, see, to get we have this number minus 7 by 8. Yes.
Ma'am, I left at the class because of the network connection. Ma'am, can you show the previous slides from I cut it from the true or false, ma'am?
Oh. This one?
Zebronics for life.
No, ma'am.
This one, right?
No, ma'am.
Yes or no? This one?
Yes, ma'am.
Oh. Taken a picture?
Ma'am, yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. So we have this rational number minus 7 by 8. What should you subtract so that you get the answer as 7 by 12? So that you get the answer as 7 by 12. So minus x is equal to 7 by 12 transpose. Disable your mic. Who's that? 7 by 12 plus 7 by 8. So minus x is equal to, the common denominator is 24. 12 into 2 into 2 into 3 into 3. So 14 plus 21. So minus x is equal to, so x is equal to minus 35 by 24.
Ma'am, I put the equation wrong, ma'am, so I got the wrong answer.
Oh.
But if I worked in that wrong equation way, but I got the answer in that way.
Okay. You
Sorry,
can't
ma'am.
simplify this any further. Yes?
Sorry, ma'am, I done it wrong.
Okay, okay. You corrected your mistake, right?
Yes, ma'am.
Yeah.
Ma'am, but I don't know how to put it in the equation form. Can you explain that?
No, see here. To get means equal to.
Yes, ma'am.
To get means, now what should be, you have the number minus 7 by 8. You must subtract something from this so that you get the answer as 7 by 12.
Yeah, ma'am, okay.
You have this number minus 7 by 8. You should subtract something from this. That means minus x.
Yes,
To get meaning so that you get the answer as
7 by 12.
So for that you should put the equal to sign. Yeah, 7 by 12. I have the number minus 7 by 8. I should subtract some number x to get, that means equal to, so that I get the answer as, that is equal to. To get means equal to. The answer should be 7 by 12. So this is the equation.
Okay, ma'am, understood.
Yeah. Yeah, do this one. Don't have to write. Don't write. Select the correct option.
Ma'am, just the option. No question, ma'am. Ma'am, we should not write the question.
Don't write down this at all. Yeah.
Ma'am, finished, ma'am. Ma'am, can I say the answer?
1 minute. I don't think. 1 second. 1 second. Yeah. What's the correct answer?
12 and 12 by 5. Only 12 and 12 by 5.
Numbers that can be written in the form m by n, where m and n are integers and not equal to 0 are called rational numbers. Which of the numbers in the list below are rational numbers? So Anirudh, you said 12 and 12 by 5, is it?
Yes, ma'am.
Okay, the others? No explanation. 1 second. Online children, use the emoji, raise your hand.
Ma'am, 12 and 12 by 5.
Ma'am, 12 by 5.
Danvin, Anirudh, Sahasra, Akshita, are you there? Srijit and Akshita?
Mom.
12 by 5.
Okay. Okay, fine.
12 and 12 by 5.
Okay, that's your option. That's your option, Anirudh. Others?
Mom,
Done
I
with?
think all of them, Mom.
Ma'am, all of them.
Mom, all
Done
of
with?
them.
12 by 5. Only 12 and 12 by 5.
Okay, Sahasra only 12 by 5. Okay.
Ma'am, all of them.
Mom, all of them.
Correct. The correct option is all of them. All of them. All of them is the correct option because 12 by 5, integer by integer, rational number. What is 12.5? It's a terminating decimal. And terminating decimals are rational numbers. Terminating decimals are rational numbers. And 12.5 is nothing but 125 by 10. This is integer by integer rational number. 12.5 is 125 by 10. And you can simplify this to 5 25s are 5 2s are. So 25 by 2. Integer by integer rational number. It's a terminating decimal. So straight away it's a rational number.
Ma'am,
The
if they
terminating.
put 3 dots next to the number like 12.5 and 3 dots, it is a non-terminating decimal, so it is not a rational number.
So if you write 12.555 and then put the dots like this, it is a rational number because it's a non-terminating repeating decimal. So it is a rational number.
No, no, ma'am. I'm saying like 12.54334 and 729 like that.
Then that is a non-terminating, non-repeating decimal. So it's not a rational number. It's an irrational number.
Yes, ma'am.
So here this is in the form m by n. So it is a rational number. This is a terminating decimal. So it is a rational number. 12 is 12 by 1. It is a rational number. So all of them, the correct option is all of them. Yeah, this is the next question.
Mom, we should write this question.
No. A pizza is divided into equal slices as shown. What part of the pizza what part of the pizza below would remain, meaning will be left over if you ate 2 of the slices?
And
So
0.4.
you eat this and this. So what will be left? This and this and this will be left. So you'll have to select that from the options here.
Mom, I think it's option A, Mom.
Option A.
Ma'am,
Okay,
me too.
Okay, so
0.4.
you eat this and this. So how many slices are there? 1, 2, 3, 4, 5, 6 pieces. 2 by 6 you eat. So that means 4 by 6 is left. And what is 4 by 6? 2 by 3. And divide 2 by 3. 0.6 are 18. 2 remains 0. 6 are 18. 2 remains, so 0.66. You eat this portion and this portion. So 1, 2, 3, 4 pieces are left. So what is left is 4 by 6 or 2 by 3. 2 by 3 is left. 2 by 3. And what is 2 by 3 as a decimal? Because all the options are decimals. So what is 2 by 3 as a decimal? 2 means 2.0000. 2 means 2.00. So 3. 2 is not sufficient, no? So you'll have to take 20. 2 is not sufficient, so you take 20. But it's after the decimal point. So keep a decimal point. 3, 6 are 18. 2 remains. 0 comes down. 6 are 18. 2 remains. Another 0 comes down. 6 are 18. 2 remains. Okay, so it goes on like this. So it is 0.6 recurring. Okay. 0.6 recurring. That means 0.6666. It goes on like that. So what we do now to round off this number, we take away the last digit. See, this is actually going on forever. Okay, so here we have this option. Closest to this one is this option. Why? Because 0. Take 4 sixes. So now when you round off this one, when you round off this, you must take away the last 6 and increase this one by 1. So it becomes 0.667. How do you round off? If the last digit is more than 5, remove it and increase the previous digit by 1. That's how you round off.
I can't understand, ma'am.
If you want to round off, take away the last digit.
No, ma'am, I can't understand division, ma'am.
I haven't finished. I haven't finished. Avinash was asking me something.
Yes, ma'am.
Actually, the answer is a non-terminating repeating decimal 0.66666. It's going on forever. That's the answer. What's the answer? It is 0.666. It's going on forever. But 1 second, just a second, children. Yeah. Now, in the options, you don't find this answer 0.6666 going on forever. You don't find. They all look like terminating decimals. So what you should do is, now how many, look at all the options. So you know this only is the correct option because 0.66, but it's 7. So you know it's kind of, this is the closest option. So how do you understand that? There are, just write 4 6s, take away the last 6. Now this 6 is more than 5, right? So when it's more than 5, increase the previous digit by 1. So it will be 0.667. That's how you round off. Now supposing it is 0.3333 going on forever. Then just take 0. Some 4 3s if you take away the last digit, and it's less than 5. The last digit is less than 5. So the answer is just 0.333. You should not increase by 1. Only if it is more than 5, if you remove the last digit, and if that last digit is more than 5, you should increase the previous digit by 1. If it's less than 5, just take away the last digit and leave it.
Mom, I have a doubt, Mom.
Yeah?
Mom, you told that the number more than 5, we can cancel it out and add it to the previous number. Like, what if the number is like 0.555?
That's if it is, I said more than 5, no? So if it is 5 also, you should just remove it.
Okay, Mom.
I said more than 5. So 5 is not more than 5, no?
Yes, Mom.
If the number is more, if the digit is more than 5. So if it is 5, just remove it.
Okay, Mom.
Yeah. Yeah. But yeah, so supposing you had the option 0.666, if you had this option, select it. Or if you had this option 0.6 recurring like this, supposing it was like this, then select that option. You're not finding the correct answer here. So what you should do is, you should understand this, that this is the option, the correct option. And how do you like get this answer from your answer? That's what I was explaining. Take 4 6s, take away the last 6, increase this one by 1 because there's more than 5. So that's how you get this answer, 0.667. All right?
Yes, Mom.
Yeah. Yeah, do this one. Take down this question and answer this. You don't have to write the others. They're all easy, no? Send the image also. If you want, you can complete your classwork. Like you can just work this and copy it later also. They're all different questions, no? So the order is not important. They're all different questions. The length of different types of several tiles are given. Write these numbers as rational numbers in the form P by Q and arrange the widths. Why widths? Arrange the lengths. Arrange the lengths in ascending order. So what is this as an improper fraction? 89 8 by 9? 800 and
809 by 9.
okay. Very good.
Next one is 346 by 5.
345, huh?
346
346.
by 5.
Okay. So what will be the LCM of the denominators? Can you guess? 100, 9, 500. Yes, without cap. Correct. 900. Correct. $900 is the LCM of these denominators: 100, 9, 5, and 100. Because the largest denominator is 100. So just say the tables of 100, 100, then 200. Now 200 will come in 5 tables, but not 9 tables. Then 300, 309 tables, no. 400, no. 500, 9 tables, no. 600, what about 600? Is 600 divisible by 9? No. 700? No. 800? No. 900. You can find the LCM using the formal method like this, taking 100, 9, 5, and 100. You can find it like this, or you can just guess. 100 is the LCM of the denominators. LCM of 100, 9, 5, and again 100 is 900. So 2897 by 100 into 9 into 9. Five into what is 900? You must tell me. 90, you said?
180.
180. 180. Please complete this and tell me. And then you can arrange the numbers in the ascending order.
Ma'am, if possible, we should cancel or we should just multiply.
Don't cancel. If you cancel, then how can you compare?
We should just multiply.
Just multiply, yes. Bring all the fractions to the same denominator. Then compare their numerators so that you can arrange the numbers in the ascending order.
Same denominators?
Now, using the LCM, we brought all the numbers to the same denominator, right? 900.
Yes, ma'am.
Yeah. So when they're all in the same, when all the numbers have the same denominator, you can compare the numerators and arrange the numbers in the ascending order.
Okay, ma'am.
If you cancel, you'll go back to the original fractions, 2897 by 100.
Ma'am, understood.
Yeah, Sahasra, what is 2897 into 9? Shrijit, Akshita, Dhanvin, Anirudh.
Ma'am, 26,700.
26073 by 900.
By 900, correct. Next one is 80900 by 900.
Ma'am, next one is 64800 by 900.
Dhanvan, I hope you did not use a calculator.
Ma'am, no, ma'am.
Okay, good. 6, repeat, 6.
64800.
346 into 180. I am using a calculator. And my calculator says 62280.
Okay, ma'am, I'll check, ma'am.
Yeah. The last one, children. 61. How 0? 4 9s are 36, no? Let me find the product and then take your answer. Divided by?
61056.
Is this correct? This product, is this correct?
Yes. Yes, ma'am. This is only correct answer, ma'am.
Ma'am, yes, ma'am.
Now, which one comes first? Which is the smallest?
Ma'am, smallest one. 26,000. Ma'am, 26,073. 26,073.
Second one?
61,056. 62,000. Third one 6228.
62,280.
Ma'am, should we write the numbers in the multiplication like 26,073 or 28.97?
Should write the original numbers.
Yeah, ma'am.
Actually, now we have followed the instructions in this question to compare. Otherwise, you don't have to do all this. We directly know. See here, somebody's mic is enabled, disable your mic. See, just by looking at the numbers, you can say, because this is 28, this is 89, this is 69, this is 67. So directly you can arrange them. You don't have to, like do this lengthy procedure. Because see here, this is
1 mark, like, can we, if it in like MCQ, can we like just put it?
So listen to what I have to say. See, actually, you don't have to go through this procedure at all. If supposing these numbers are given to you and you have to compare the numbers, arrange them in the ascending order, you can directly, do it because without using LCM. Why? Because this is 28, this is 89, this is 69, and this is 67. So obviously 28 is first, 67 is second, 69 is third, and 89 is the fourth one. But in the question, we have this instruction, write these numbers as rational numbers in the P by Q form. So we had to do all this. All of you understood what I said?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
All right. So the first one is what?
28.97.
So 28.97.
67.84.
Yeah, then
69 1 by 5. 89 8 by 9.
89 1 by 5. Last 89 by 8 by.
you can also use a less than symbol. Like you can also write like this, 28.97 is less than 67.84, is less than 69 1 by 5, is less than 89 8 by 9. You can also leave your answer like in this form.
Ma'am, I heard out, ma'am.
Yeah.
Ma'am, can we also write the increasing order of the products, ma'am?
Increasing order, huh?
Yes, ma'am. The ascending order, ma'am. Can we write it like the with of the products using the products?
No, I don't know why I'm not able to get your question.
No, ma'am. I'm asking that can we write the ascending order using the products, ma'am?
Into.
Yes, ma'am.
Oh, this. No. If you write that, you should also write this.
Oh, so we can write both, right?
You can write both.
Oh, okay, ma'am.
You can write both the answers.
Okay, ma'am.
Word problems will take up another day.
Ma'am,
Yeah.
ma'am, today I had my exam, ma'am. I done well in the exam.
Very good. Share your question paper later.
Yes, ma'am. After the class, I will share.
Yeah. One second. I'll just complete this. Yeah. We'll discuss first and then you can write out the question and answer. So the heading is simplify using appropriate property or properties. You should simplify using appropriate property or properties.
Ma'am,
Okay.
distributive property.
One second. Okay. So look at the expression given. In the first bracket, you have 3 by 8 into minus 4 by 5. Second bracket, 7 by 9 into 3 by 8. Then in the third bracket, 3 by 8 into minus 8 by 10. So we see that in all the three brackets, 3 by 8 is common. 3 by 8. 3 by 8 is common in all the three brackets, right? So this is the given question. This is the question given. Write that. Put an equal to sign or take an equal to sign. Whatever is common, write that out. 3 by 8 into, in the bracket, see here. Now this one is common. So write this one inside the bracket, minus 4 by 5. Then put this plus sign, plus. 3 by 8 is common. So write 7 by 9. Then this minus sign, this minus sign. 3 by 8 is common. So write this one, minus 8 by 10. Because there's already a sign here. And this also carries a minus sign, minus 8 by 10. Put this in a bracket and close the bracket. That's the first step. I'll repeat the first step. 3 by 8 is common. write that outside once. Multiplied by, in brackets, write this plus, write this minus, and it's minus 8 by 10, right? So minus and in bracket minus 8 by 10 and close the square bracket. This is the first step. Now, minus into minus is plus, right? Minus into minus plus, here you can cancel. 2 4s are 2 5s are, you can cancel. So next step, 3 by 8 as it is, minus 4 by 5 plus 7 by 9. Minus into minus plus 4 by 5. And then after this, take the LCM and simplify. Sorry? Why? Okay, sorry, I didn't notice that. Yeah, plus minus 4 by 5 plus 4 by 5 gets cancelled. I didn't notice that. So that's why you have 7 by 9, 3 by 8 into 7 by 9. So it's nothing but 3 into 7 by 8 into 9. Simplify. Simplify. 3 1s are, 3 3s are. So the answer is 7 by 24. You don't have to put this bracket. You can remove this.
Mom, I have a doubt, Mom.
Yeah.
Mom, actually in the second bracket, Mom, why the 3 by 8 is written in reverse form, Mom? Actually, 3 by 8 actually should come in first. Like the formula, I think the question should be like 3 by 8 into 7 by 9, right?
Yeah, but you know that by the commutative, property of rational numbers, 7 by 9 into 3 by 8 is nothing but 3 by 8 into 7 by 9.
But inside the other brackets, 3 by 8 is written first, Mom. So I'm asking, Mom.
It's okay. It
You
can
can
be
also
anywhere.
take that, Mom.
Because 7 by 9 into 3 by 8 is the same as 3 by 8 into 7 by 9. So you can just treat it like this. So 3 by 8 is common everywhere.
Oh, okay, Mom.
Yeah. Write down, all of you.
Done, ma'am.
Okay.
Ma'am, 1 minute, ma'am.
Yeah.
Done, ma'am.
Okay. Completed, Harini? Yeah.
She coming?
Disable your mic. Who's that?
Sorry, ma'am.
Yeah. This is the next question. Yeah. So wherever there's multiplication, use brackets. See, this is the question itself. This is the question, and I have repeated the question. I've written the question again here because I have to insert the brackets accordingly. Okay, so see here, where there's multiplication, see here, this rational number into this rational number, because we know that multiplication dominates other operations, right? Multiplication dominates addition, subtraction. So where there's multiplication, see here, where is it multiple? This is the multiplication sign, children. What do you have to the left and right of it? These two numbers. No, so put a bracket. Am I clear? Now here there's a multiplication sign. So there's 3 by 5 and 1 by 6. No, put a bracket. Do you understand that? Because multiplication is a dominating operation when compared to addition and subtraction. So we see the multiplication sign here. So use a bracket, simple bracket. Then the multiplication sign here. So use a simple bracket. 3 by 5 into 1 by 6 minus 2 by 3 into 3 by 5. Plus 5 by 2 is in the middle. Okay. No, I will not repeat this. If you have a doubt, tell me now. This is the question. This is the given expression. I wrote that again and I've inserted the brackets. Because multiplication comes first, then addition, subtraction. Where there is multiplication, we have used simple brackets because we need to simplify that first. So is this understood, all of you online?
Yes, ma'am.
Yes, ma'am.
Okay.
Mom,
All right.
mom, can you repeat it again, mom?
Now, which operation will you do first? Addition, subtraction, or multiplication?
Mom, multiplication, mom.
Can we, where, in how many places do you see the multiplication sign here?
4.
How many places? 1, 2, 3, 4. How many places do you see the multiplication sign? This sign.
Mom, 4, mom.
I can see only in 2 places. How can you see it in 4 places?
Mom, before the equal to sign.
How many multiplication signs do you see here?
2, mom.
Yeah. Now, before this multiplication sign, there's minus 2 by 3. Start the bracket there. After the multiplication sign, there is 3 by 5. Close the bracket there. Before, disable your mic, Akshita. Just listen to me. Yeah. Now, before this multiplication sign, there is 3 by 5. Open the bracket there. After the multiplication sign, there's 1 by 6. Close the bracket there. Got it?
Okay, mom.
Okay.
Yes,
Next
ma'am.
step. Okay. Next step, inside the bracket, you can simplify. 3 and 3 cancels. And here 3 1s are 3 2s are. Inside the bracket, you can simplify. Do it along with me, all of you. You can simplify inside the bracket. Cancel 3 and 3 in the first bracket, 3 and 6 in the second bracket. Now after this, what remains in the first bracket? Minus 2 by 5, right? That minus 2 by 5. You don't have to put a bracket now because that's the answer. This is the result. Plus 5 by 2 minus
1 by 6. 1 by
1
6.
by
6. Ma'am, 10, 10. Minus 1 by 10.
minus 1 by 10. 5 2s are 10.
Ma'am, first we should do addition or subtraction, ma'am, here.
So anything, whatever comes, you can do addition and subtraction together also. But in the
Ma'am,
rule,
like taking LCM for everything.
addition comes first. Actually, when you have addition and subtraction, you can do anything first, whichever comes first from the left. Addition, subtraction, though the rule is like this, addition, subtraction have equal weightage. Whichever comes first from the left, do that first. Whichever comes first from the left, whichever comes first. So you do these two first. Get the answer, and then with that answer, you can do minus 1 by 10. But what you can also do is when it is only addition and subtraction, you can do all of them together also. When the expression has only addition and subtraction, you can do all of them together. Only plus minus is there, nothing else is there. You can do all of them together. Which one? So if you want to do 2 at a time, then do these two. So the LCM is 10. So it will be minus 4 plus 25 minus 1 by 10. Because you'll have to multiply minus 2 by 5 into 2 into 2 is minus 4 by 10. And 5 by 2 into 5 into 5. 25 by 10. So it's minus 4 plus 25 by 10 minus 1 by 10, which is 21 by 10 minus 1 by 10, which is 21 minus 1 by 10, which is 20 by 10, which is 2. Correct. When you have addition, subtraction, you can do all of them together. If you want to follow the rule, you can do all of them together. You'll get marks. If you strictly want to follow the rule, from the left, whichever comes first, do that. So see, I've done that. From the left, I've done these two. From the left, from this side. Take the first two fractions, simplify them. With that result, take the third one.
Done, ma'am.
Finished, all of you?
Yes, ma'am.
Okay. Yeah, this is the next one. One second. Just a second. So what you have to do is write the expression again. And then insert brackets. So how many multiplication signs can we see? How many multiplication signs can we see? 3. Insert bracket. Start the bracket. See, this is the multiplication sign. This is the number. 2 by 5 is the number before that. Start the bracket before that. Now there's already a simple bracket, so you can use a square bracket. So start the square bracket here. And what's the number after the multiplication sign? Minus 3 by 7. So there you close it. Okay, now this is the next multiplication sign. What do you have before that? 1 by 6. Start the bracket before that. And after the multiplication sign, 3 by 2. Close the bracket after that. Then again the multiplication sign here. We have 1 by 14 before it. So here you start the simple bracket and close it here. So we have 3 sets of multiplication. Now, here you cannot simplify. In the first bracket, no cancelling happens. So multiply the numerators. 2 into minus 3 is minus 6 by 7 5s are 35. In the second bracket, we can cancel. 3 1s are 3 2s are. So minus 1 into 1, 1, 2 into 2, 4. Multiply the numerators, multiply the denominators. For multiplication, you should not take LCM. LCM is only for addition, subtraction. For multiplication, multiply the numerators, multiply the denominators. The third bracket, 2 1s are, 2 7s are. 1 into 1, 1. 7 into 5, 35. Yeah.
Ma'am,
So that's
140. 1 by 4 and plus 1 by 35. The LCM
see what we are doing, we are rearranging. That's what I said. Addition, subtraction have equal weightage. You can do anything first. That's what I said. So you can now simplify like this. You can take this first and then do this. That's what I meant by saying addition, subtraction have equal weightage. You can do anything first, or you can do all of them together also. Anyways, it's fine. So see, you can change it like this. So 35 is the common denominator. Minus 6 plus 1 is minus 5. Minus 1 by 4. 5 1s are, 5 7s are. So it is minus 1 by 7 minus 1 by 4. Now the LCM is 28. So what will come in the numerator?
Ma'am, minus 4
Minus 4. Then
and 7. Minus 4 minus 7.
because into 4 you should do 7 4s are 28. Here into 7.
Yes, ma'am. Minus 11 by 28.
This is the answer. Minus 7 by 28 is the answer.
Cancel. I'm done, ma'am.
Yeah. Yeah, this is the next question. Yeah, children, taking the question. So write the question and write it again.
Ma'am, finish the answer. Ma'am, answer completed.
Okay, please wait.
Okay.
Minus 3 by 7 minus 1 by 14 minus 3 by 7 into 3 by 5. Repeat that after the equal to sign because we need to insert brackets. We have the multiplication sign in 2 places. This is a new question, right? Or did we do this earlier? This is a new one, right? Did we do anything?
Ma'am, yes, ma'am. Ma'am, it's a new sir.
Okay, yeah, okay. So first, this is the first step. Now insert brackets. multiplication sign, open, close. Multiplication sign, open, close. Don't take the minus. See, this minus you have to take inside bracket. This minus should be outside the bracket. Don't put it like this. There should be a connecting sign, no? So leave the sign. Start the bracket here before 3/7. Don't put minus also inside the bracket. So this is the first step. Now what you see here is in these two brackets, we have 3/7 common. But this is minus 3/7. This is plus 3/7. I want to take out common 3/7, but this is minus 3/7. This is plus 3/7. So what you can do is you can put this minus sign here. You can write this as minus 2/5 into 3/7, minus 1/14, minus 3/7 into 3/5. See, because what is 5 into minus 3? Minus 15. If you put the minus sign here for 5, minus 5 into 3, that also is minus 15 only. So you want to take out 3/7 common, but it's minus 3/7 in one bracket and 3/7 in the other bracket. So you just put this minus sign for this number 2/5, which is inside the same bracket. So minus 2/5. So next step will be minus 2/5 into 3/7 and the rest as it is. Okay. What you can do is you can also, okay, we'll write that in the third step. Or what you can also do is you can put this bracket together here. Minus 3/7 into 3/5. It's rearranging the terms. Minus 1/40. It's rearranging. See, I'm pausing so that you can ask me if you have any questions. Yeah, anybody? Please ask me. Okay. I've just put this minus sign for 2/5. So minus 2/5 into 3/7. And then this bracket, disable your mic. This bracket, I've just exchanged the places. These two numbers I've just exchanged the places. Now you can use the distributive property of multiplication over subtraction. This is common. So A, this is common, A. This is B, this is C. A into B minus A into C is equal to, if you want, I can write the property here. The distributive property of multiplication over subtraction. What is that? A into B minus A into C is equal to A into B minus C. I've marked CA. The common number is A. A is 3/7. It is common. Then B and C. So what is here is of the form A into B minus A into C. So the answer is A into, what is A, Harini? 3/7 into B minus C. What's B? Minus? Yeah, B minus C. Minus 3/5. So this is according to the rule. Then what is the other number I should write? Minus 1/40. Okay. Very good. Now 3/7 into, now this is subtraction. Inside the bracket is the subtraction. So take the LCM. It's already common, 5. So minus 2, minus 3, minus 5. So minus 5/5 you get. Minus 5/5. 3 by 7 into minus 5 by 5. If you want, you can put it in a bracket, minus 1 by 14. So 5 and 5 will get cancelled. So it's 3 by 7 into minus 1. What is 3 by 7 into minus 1? Minus 3 by 7. So we have we have 3 by 7 into minus 1. Minus 1 by 14. So when you multiply 3 by 7 and minus 1, you get minus 3 by 7, minus 1 by 14. Common denominator 14. So you should do into 2 here, into 2 into 2. So it'll be minus 6 minus 1. Here it is into 1. So minus 7 by 14 minus 1 by 2. You have not completed. You have to write from here, Harini? Yeah.
Finish.
Okay. Finished?
No, ma'am.
No? Okay. 1 second, Harini.
Finish, ma'am.
Yeah.
I'm finished.
Okay. Completed? Yeah. Very good. Here the brackets have already been inserted, you can see. Just you can copy it later. Sorry? He'll wait? Okay. So the question, in the question, we can see the brackets are already there, right? We can see the brackets are already there. Minus 3 by 7 into 2 by 5 plus minus 3 by 10 into minus 3 by 7 minus minus 3 by 7 into 7 by 30 plus 3 by 20 into minus 3 by 7. So what is common here? I'll write it in the next step. What's common, children? See here. Minus 3 by 7, minus 3 by 7, minus 3 by 7, minus 3 by 7. Everywhere minus 3 by 7 is common. So take out that minus 3 by 7 common. And in the bracket, you must write the remaining numbers 2 by 5.
Ma'am, I have doubt.
Yeah.
Ma'am, minus 3 by 10 there is, ma'am. Minus 3 by 10 minus 3 by 7.
Yeah, I have taken the common factor. What's common everywhere? Minus 3 by 7.
Here, the first term minus 3 by 7 into 2 by 5. Okay, ma'am. In the second term minus 3 by 10 into minus 3.
Okay, wait. Let me clarify that for you. 1 second. So we know that rational numbers are commutative, right? Under multiplication.
Yes,
So
sir.
you can, since you're not able to understand, I can give you one extra step. So you write minus 3 by 7 first and then minus 3 by 10. Is this correct? Because A into B is equal to?
B into A.
Yeah, is that correct?
Yes, ma'am.
Now the last one also, you can write it like this. Minus 3 by 7 into 3 by 20. Okay?
Yes, ma'am.
Now minus 3 by 7 is common everywhere, right?
Yes, ma'am.
Okay, now what should you write?
Ma'am, minus 3 by 7 into 2 by 5.
This sign plus
minus 3 by 10.
Then yeah, this one minus 3 by 10. Then write the sign
7 by 30.
Then this sign
3 by 20.
plus
3 by 20.
Correct. Let's write all this and close the bracket. So this will be minus 3 by 7. Very good. Yeah. Now you can open a simple bracket and write 2 by 5. Plus into minus is minus. Plus into minus minus. So 3 by 10 minus 7 by 30 plus 3 by 20. What's the LCM? You can see now you don't have to do 2 at a time. You can take everybody together. Take all of them together. What's the LCM? 30. 60.
Ma'am, yes, ma'am, 60.
60 is the LCM. So into 12 into 12 into 6 into 6 into 2 into 2 into 3 into 3. 24 minus 18 minus 14 plus 9. Correct? Minus 3 by 7. Open bracket. 24 minus 18, 6. Minus 14 plus 6, minus 8. Minus 8 plus 9, 1. 1 by 60. Please check if I'm right. Into 1 by 60. So now 3 ones are 320 times. So it is minus 1 by 140. 1 into 1, 1. 7 into 20, 140. Minus 1 by 140.
I'm finished, ma'am.
Yeah, good. Sorry. Minus 1 by 140. Done, all of you? Yeah, you can write it. Done, all of you?
Yes, ma'am.
Yes, ma'am.
I'll wait if you have not finished. Okay. So that's it for today's session, children. Thank you so much. Good night. You can stay back and complete. If you have not finished writing this, you can stay back and complete. I'll be presenting my screen. I'll just end the recording now. Thank you.
Thank you, ma'am.
Ma'am.
Thank you.
Thank you, ma'am.
Thank you, children. Good night.
Good night, ma'am. Thank you.